We are on question 3, and question 3 says, in the diagram below, we have A, which is -1 and 4. And then we have B, which is P and -2, and C are vertices of triangle ABC. And then they tell us that E is the y-intercept of this line AB. So if you have the equation of this line, you can find E. And then they also tell us that F, which is 0 and -4, is the midpoint of BC. And we have the angles of inclination of AB and AC are 135 degrees and alpha, respectively. The first question is to calculate the gradient of AB. Okay, let's look at the line of AB, A to B. Do you see that B is missing? So there's no way you can find the gradient by using the gradient formula. However, you see that we have 135 degrees. That is the angle of inclination of AB. And we can actually use that to find that gradient. So this is what we can do. You can say the equation for the angle of inclination is tan theta must be equal to your gradient. And the theta that is referred to here is the angle of inclination of that line. So of that line AB, which we can see over there, is 135 degrees. So it means we can substitute that there. So to find the gradient, you're just going to say tan of 135 degrees. Now, you can go ahead and reduce this using your trig reductions. So this means that your gradient is tan, and 135 degrees falls into or falls within the second quadrant, which is where you have 180 degrees minus theta. And this is, of course, sine's quadrant, right? So when you're reducing it, you're really saying 180 degrees minus what angle gives you 135 degrees. And that's going to be 180 degrees plus or minus 45 degrees, right? And then if you reduce this, because this is in sine's quadrant, it's going to become negative. So our gradient is negative tan of 45 degrees. And you can use your calculator, but tan 45 degrees is always going to be equal to 1. So this means that the gradient here is -1. Okay, so that is our answer. The gradient is -1. Moving on to the next question. Then the next question is, show that the value of P is 5. Very simple. Since we have the gradient of AB, right? Because you see that P comes from this line where AB is. We have the gradient of this line. Okay, to find P, all you would have to do is use your gradient formula. It's the only thing missing. So we can go ahead and say, okay, the gradient of AB is found by saying y2 minus y1 over x2 minus x1. That's all we have to say here. Now we already know the gradient, so we can substitute that in place of gradient. And then y2 minus y1, we can just go ahead and say -2 minus the 4, so -2 minus 4 over, and then x2 minus x1, that is the P minus -1. And of course, if you say P minus -1, they multiply and become a plus, so that's P plus 1. So when you simplify this, you get -1. I'll just continue writing here. There's no use going to another page. So -1 equals, and that subtract -2 minus 4 is -6. You have P plus 1. Let's just go ahead and cross multiply. It's just easier in this case. So -1 times the P plus 1. Remember, -1 multiplies to P, giving you a negative P. -1 must also multiply to +1, giving you a -1. And then here you have a denominator of 1, and that multiplies with your -6, giving you a -6. And then we can take negative P over to make it positive. And then we'll take our -6 over to make that positive, and you still have a -1 here. So that's 6 minus 1, and therefore P is equal to 5. There we go. Okay, so because it's the only thing missing, we could actually use that to find that. Okay, moving on to the next question. The next question says, calculate the coordinates of C. Okay, let's just put that we know P now. P is 5, so 5 and -2 there. They want us to find C. Well, what do we know about C? We know that C is part of this line that they told us the midpoint is F, okay? Since we already have the midpoint of this line, okay, and we're looking for C, we can just go ahead and call C X and Y. and then use the midpoint formula to actually find this. So we have the midpoint of this, okay, of CB or BC. Let's call it that. So we have the midpoint already of BC. B is that point 5 now and -2, and then C is the point we don't have. But the midpoint of BC, we have this already. This is F. That's what they told us. They told us F is the midpoint. That's why these two are equal. So we're going to keep that in mind and say, okay, the midpoint is already 0 and -4. And let's use this to actually find it. So we're using the equation of midpoint. So midpoint is equal to, you don't have to say equal to, but it's fine. X1 plus X2 over 2. And then y1 plus y2 over 2. Remember, grade 12s, this is in your formula sheet, okay? And then we're going to go ahead and say, well, we already know the midpoint of this. It is this. It is 0 and -4. And this is equal to, now here, this is how we would find the midpoint by using this calculation. However, we do already have the midpoint, okay? So it means that you can take that as your x1. I just want to put the x first, that's why. And then I'll take that as my x2. And that's my y1 and my y2. So this is us calculating the midpoints, but we already have it though. So to calculate this, we'll say x1. And the x1 here is x. So we're saying x plus x2, which is 5 over 2. And then y1, which is y, plus -2, which becomes a -2, okay, over 2. So on one side, you have the calculation for the midpoint of BC. On the other side, you have the actual midpoint of BC. This means that they are actually the exact same thing, okay? Because if you actually calculated this, if you had x and y, you would have the exact same point since they're the same thing. And so what we're going to do is equate the x values. We'll tell them that 0, the x value of 0 here should be equal to the x value here, which is x plus 5 over 2. And the y value of -4 should be equal to the y value over here, y minus 2 over 2. Okay, let's go ahead and simplify. So you have over 2 here. You can just cross multiply, it's fine. So put this over 1. 0 times 2 stays 0. And then 1 times x plus 5 is x plus 5. Okay, so x plus 5 is equal to 0. And then you take your 5 over. So x is equal to -5. And then the y value, okay, you can also just cross multiply. So put this over 1 and then cross multiply. So that multiplies. 1 times anything stays exactly the same. -2 times 2 is -8. Then you can take your -2 over. So that's y equals, it becomes a +2 minus 8. And +2 minus 8 is going to give you a -6. So you see that C, now the coordinates of C are -5 and -6. Okay, and that is that answer. We can also fill that in our diagram so that we know we have -5 and -6. Okay, moving on to the next question. 3.4 says, determine the equation of AC in the form of y equals mx plus c. So that's 3.4. We have to find the equation of AC. Well, we have everything. We have A and we have C. So we just have to use the equation of a straight line to find this. So let me put down the coordinates and then we can go ahead and find this. Okay, so here are our coordinates and we can find the equation of AC. So let's go ahead and find the gradient first. So the gradient is equal to y2 minus y1. I'm not going to write the formula again because we already have it. So y2 is -6 minus 4 over, and then the x2 and x1. So that's -5 minus -1, which becomes a +1, of course. Okay, so you can use your calculator to simplify that. When you simplify that, that gives you a -10, right? And that gives you, that's like saying 1 minus 5, which is -4. And you see that they will both become positive, and they both have a common factor of 2. So if you divide 10 by 2, you get 5, and you divide 4 by 2, you get 2. So that is your answer. Okay, our answer is 5 over 2 as our gradient, and then we just have to find the equation. So you can use the y equals mx plus c, substitute, then find your c, and then put it in your equation. Or you can use this, the y minus y1 is equal to your gradient, which I have, all right? and then x minus x1. Now you just leave it as m for now. So, and then x minus x1. Okay, now let's go ahead and substitute. With this, you just need the gradient and 1 point. Try to take the simplest point. I'll take the -1 and 4. So that is our x1 and our y1. So y minus y1, and our y1 is 4, and is equal to 5 over 2 multiplied by x minus your x1, which is -1. So if you multiply, of course, that becomes a +1. Then just simplify. So this is, I start here, 5 over 2x. When you multiply that, that becomes a +5 over 2. And then your -4 comes over and becomes a +4. Then we can leave the y here. Okay, then we just have to add those. So y equals 5 over 2x. And let's see how we're going to add this. So put this over 1. Then just make the denominators the same, or you could just use a calculator. So that becomes 8. So it's saying 8 plus 5, which is 13. And then over 2. So that's our answer. Our answer is 5 over 2x plus 13 over 2. And that is our final answer. Okay, moving on to the next question. In the next question, they want us to calculate the size of angle CAB. So let's look at our diagram to understand where exactly that is. So CAB. So it's this angle over here. So normally when I'm calculating the size of an angle in analytical geometry, I usually like to extend the lines and then find out exactly how that was created. But in this one, I'm going to take a different approach. So with this, and the reason I'm taking a different approach is because this diagram actually just works well for it. I want you to look at this as, look at your triangle. You have this triangle over here, right? This is a triangle that you have. And do you see that if you extend like this, 135 degrees is your exterior angle of this green triangle highlighted. So it would mean that if you add this angle CAB, and you add the angle alpha, you're going to actually get that. So in order to find this over here, all you need is alpha. And I'm going to actually focus on getting that. And here's the reason why. You see, the previous question asked us to find the equation of this line. So because we have the equation of this line, we also have its gradient. So we can actually find its angle of inclination. So let's find the angle of inclination here, that size of alpha, and it will help us find our CAB. Okay, so we have the gradient of AC. Let's go ahead and say that to find that angle of inclination, we say tan theta, I'll just say alpha in this case because we know what that is equal to our gradient of AC. And we know that the gradient of AC is 5 over 2. So 5 over 2. Then it means that alpha is equal to shift tan, or the second function of tan, 5 over 2. And it gives us this, okay? So in this case, I would actually say it's fine. You can round off to 2 decimal places because you see the other angle you're working with is 135 degrees, which is already a whole number. So you don't have to really worry about decimals here. So 68 point, and then that rounds up to a 1, and then that rounds up to a 2. Okay, so that just becomes, let's just put it in 2 decimal form. So 20 degrees, right? That's what we have there. So since we have alpha now, we can actually use this here. So it's saying that this is 68.20 degrees. And in a triangle, we know that the exterior angle is equal to the sum of the 2 opposite interior angles. So it means if you take angle CAB plus alpha, it must give you 135 degrees. And that's exactly what we're going to write. So CAB, right, plus that 68.20 degrees should give us our exterior angle of 135 degrees. You don't really need reasons. You can if you want, but that's really just because this is not Euclidean geometry. They don't really ask for reasons. Then let's go ahead and solve for CAB. Okay, so that's 135 degrees minus 68.20 degrees. And that would just be our answer there. So the answer we get is 66.8. So that is our final answer in this question. Okay, moving on to the next question. The next question, 3.6, says calculate the area of triangle BEF. Okay, so let's go ahead and look at that triangle BEF. Okay, so it's this triangle. I'll highlight it in blue. So BEF is going from B to E to F. So this is the triangle they're referring to. And we have to find the area of this triangle. Okay, remember that you have two area rules. Okay, you have the one where you don't have a perpendicular height, and you have the one where you have a perpendicular height. Okay, so let's just see which one would suit this. Also, just remember the mark allocation for this question. It's only 3 marks. Okay, so it's not really a long thing that we have to do. So let's think about it like this. So before actually using the formula for the area of a triangle without a perpendicular height, you need to first make sure that the one with a perpendicular height can be used. Okay, you have to try and check whether it can be used or not. It's better to do that way. So let's look at this. Does it have a perpendicular height? Well, not one that they indicate. However, we are at an advantage here because do you see that we can treat this as the base? EF can be our base. And because it is on the y-axis, we can see that this is a vertical line. Okay, so it's not slanted in any way. It's perfectly flat. So to find a perpendicular height, we would have to go to the highest point of this triangle. So kind of tilt your head this way, and you're looking at this as if this is the base of the triangle. What would be the highest point of the triangle? It would be B. So if you go from B and you are going to draw a horizontal line, right, to the y-axis, that would serve as your perpendicular height. Okay. Now, for us to actually use it like that, we need to ensure that we actually take the correct height here. Because B is the highest point and it's 5 and -2, it means that from the y-axis, or really the origin, okay, you can look at it from the y-axis really, you went exactly 5 units to the right to get to B. So it would mean that this perpendicular height is exactly 5 units. As you can see, it's a horizontal line. So we have a perpendicular height. We have a height, and then all we would need is a base. So the base is E all the way to F. If you say the y value of E minus the y value of F, you will find it. Okay, so we can actually use this method. So E, as you can see, is on your y-axis. Because it's on your y-axis, it's the y-intercept of this line AB. What do we know about that line AB? Do we have the equation of it? Okay, we don't have the equation of AB. However, we can actually find it easily. So because we already have the gradient of AB, we can actually use that. So remember, that was the first question they asked. The gradient of AB is -1. And you have a point on AB. You have 2 points, in fact, that you can use. I'm just going to go ahead and use 1 and -1 and 4 as my points to substitute to find the equation of AB so that I can find the y-intercept. That's the whole point. I just want to find C because y equals mx plus c. Okay, let's go ahead and do that. So with AB, we have the gradient of AB. So we can say that the gradient of AB, we already know, is equal to -1. And we have a point on AB, which is A, and that was -1 and 4. So we're saying y minus y1, which I'm just going to substitute in already, is 4, is equal to our gradient, which is -1, and then x minus x1, which is a -1, so that becomes a +1. So when you simplify, this is y equals -x minus 1, and take your -4 over to become a +4. And then y equals, we have -x, and 4 minus 1 is +3. Okay, so there, we know the y-intercept now. Since this is the equation of AB, the y-intercept is +3. So that is that y-intercept that we were looking for, E. That is +3. Okay, you can say 0 and +3. So since we know what that is, we can actually find that base now. So E is 0 and +3. Therefore, the base of our triangle, okay, I'll just call it a base, B equals, and we can find that by saying, since this is the base, if you tilt your head like that, you're going to say the the highest y value minus the lowest y value. So that is 3 minus -4. Okay, so we have 3 minus -4 there, which is really just 3 plus 4, and so our base is 7. Now remember our perpendicular height that we needed, we already found that. We found that to be 5 units, okay? Because it is a horizontal line, it's perpendicular to the y-axis, which is a vertical line. So we have 5 units there as our height. So we can actually find this area. So the area of this triangle, which is BEF is going to be equal to a half multiplied by our base of 7 multiplied by our perpendicular height of 5, which is equal to 7 times 5 is 35. So 35 times a half is just 35 over 2, which you can put in decimal form. In decimal form, 30 divided by 2 is 15. 5 divided by 2 is 2.5. So that is 17.5. So 17.5. And because these are in units, the area is in units squared. So that is our final answer for that question. And then we move on to the last question in question 3. Okay, last question 3.7, of course, in question 3 says another point K, which is T and T, where T is less than 0, is plotted such that AK is equal to 5 square root 5. We need to calculate the coordinates of T. Okay, so they tell us what T is. T is less than 0. They don't give us the value yet, of course. They want us to find exactly what the coordinates of K is, since we know it's T and T. So since this is negative, if you have a point and it's T, and they're both negative, it just means that it's on the negative part of the x-axis and the negative part of the y-axis. So that is going to lie in the third quadrant. Okay, so that's where that point is going to lie first of all. So let's go ahead and just use our diagram. So we have a point T, okay, in the third quadrant. So wherever it is, it's the exact same distance. So if you go T units this side, you're also going to go T units that side. So wherever it is, maybe it's just like here, right? The information that they give us is that AK, so A to K, that is 5 square root 5. And we have to find T. So you see that they give you the distance of AK. So we have to use the distance formula. So the distance formula, okay, for AK, you're going to say the square root of x2 minus x1 all squared plus y2 minus y1 all squared. And that would give us the distance, right? But we already know the distance. The distance of this line is 5 root 5, okay? And so we're going to say square root, and let's just take this as x1 and that as x2. That is y1 and that is y2. So we're just saying t minus, and our first x value is -1, so that's -1 squared. I'll just put plus 1 because it multiplies. Then plus, and we have y2, which is t again, and minus the y2, which is 4. So you see that you just have to solve for t, which is not going to be complicated because it's the same variable you're using. It's not like x and y or p and q. Okay, so let's go ahead and solve for t. So the first issue that we have here is, of course, our square roots. So we need to get rid of those by squaring both sides of the equation. And when we square this side of the equation, you see that your 5 would get squared because these two are sitting together because they're being multiplied. The 5 gets squared and becomes a 25. The root 5 gets squared, and what happens when a root gets squared is that square root cancels. So that will become a 5 on its own. So it's been multiplied by 5 is equal to, and here your square root breaks open, and you're left with what is inside, which is the t plus, and I can also just go ahead and distribute. So t plus 1 all squared, square the t, that gives you t squared. Then square the 1, which gives you positive 1. Then say t times 1, which gives you t, and multiply that by 2, which gives you positive 2t. Okay, do the same thing over here. Square the t, gives you positive t squared. Square the -4, gives you positive 16. T times -4 is -4t, and multiply by 2 to give you -8t. Okay, that's how to distribute those quickly instead of writing into brackets and then multiplying those. Those take long, and when you take longer steps, it is easier to make mistakes. So we're multiplying here. 25 times 5 is 125, which is equal to t squared plus t squared is 2t squared. Then the positive 2t minus 8t gives you negative 6t. And then positive 1 plus 16 is positive 17. Okay, we still have our 125, so we can take that over. So 0 equals 2t squared minus 6t plus 17 minus 125. So what is 17? I'll just calculate it here on my calculator. 17 minus 125 is negative 108. Okay, so we have that. Now we have to actually just factorize this and solve for t. Do you notice that each number, okay, or each value has a common factor of 2? Is common factor of 2 all through. So we can actually just divide by 2 on both sides of the equation to get rid of this common factor. So divide by 2 and divide by 2. So it means that 0 divided by 2 is 0 is equal to 2t squared divided by 2 is t squared, and then we have minus 3t, and then 108, 100 divided by 2 is 50, 8 divided by 2 is 4, so that is 54. Negative 54 is what we have over there. And now we just have to actually factorize this. So let's go ahead and factorize. You can use the quick method if you want, it's fine. So that's t multiplied by t, and factors of 54. Okay, so I know 1 would not work. 2 would definitely not work. We're going to have to use bigger factors. So I wanted to show you quicker ways to work with this. Make sure you go in order. So we're looking for factors of 54. So what times what gives you 54, right? But those numbers should also give you negative 3. The first thing we need to note is that because 54 is actually negative, one of your factors should be negative, the other should be positive. So I'm going to divide 54 by various numbers. 1 would obviously not work, neither would 2, because you see, 2 and 27 can never give you negative 3. Okay, 3, clearly too small. 4, nope, that doesn't even work at all, it's not a factor. 5, of course, is not a factor. 6 and 9, that looks more promising. So we can use 6 and 9. So we're going to take the 6 and the 9. Now decide which one should be negative so that you have a negative 3 in the middle. Okay, you want it to remain negative, so give the negative to the bigger number. Okay, so that is negative 9 and plus 6. If you multiply those, they give you negative 54, but 6 minus 9 is in fact negative 3. Okay, so those are our factors, and then we're solving for t. It means that t is either equal to, you take that over, it becomes a positive 9, or t is equal to, you take that over, it becomes a negative 6. Now, here's how we find out what exactly t is. Do you remember in the beginning here, right, in the beginning of this question, they told you that t must be less than 0, okay? Because we know where t is sitting. So it means that t is actually the negative 1. So don't take the 9. Take this. T is equal to negative 6. Okay, and that makes perfect sense. The reason you're getting 2 answers is because they're really just saying from A, right? You can actually have 2 points that will have this exact same distance, which is very possible. So you can have another line that's the exact same 5 root 5 distance, okay, over there. But that point, right, its value would have been 9 and 9. Okay, so now that we have that, we need to just conclude. K is finally equal to, so the coordinates of K, T, and T is negative 6 and negative 6. And there we go. So that's our final answer. And we finally move on to question 4. Okay, so we are on question 4. And question 4 says, in the diagram below, the circle centered at M is, we have this point, negative 2 and 3. Okay, so we have a circle centered at M, and it passes through A, which is 1 and negative 1, and C, which they do not give us over there. Then they tell us that BA and BC are tangents to the circle at A and C. So those are very important. We have tangents over there, respectively, with BC parallel to the y-axis. Okay, so this line is also parallel to the y-axis. And the first question is determine the equation of the circle in the form of, and that is in the form of an equation of a circle. So what we're going to do with this equation, just remember what these points stand for. Your A and your B, remember, those are the coordinates of the center of the circle, okay? And then the X and Y, you can leave those open. But of course, we're going to have to substitute values in it so that we can find R squared. Okay, so in place of X and Y, you're just going to find a point that actually lies on the circle. So let's go. We're going to say, first of all, X minus, and our A, the center point, that is A over here. And this is B, since these are the coordinates of the center of the circle. So that's A and B. So that's X minus -2. So minus -2, which of course becomes a +2, all squared, plus Y minus, and we have a 3 there. So Y minus 3, which is our B, is equal to R squared. So you see now that R squared is the only thing missing. So to find that, you have to substitute a point so that those are filled, and we'll be able to find exactly what R squared is. So let's go ahead and find a point that lies on this circle, which would be A. So that is our X and our Y value. So substitute 1 and -1. So we are saying 1 plus 2 all squared plus -1 minus 3 all squared. Sorry about that. I forgot that squared. Is equal to R squared. Okay, so let's go ahead and substitute this onto the calculator just to make things quicker. And so you see that R squared is equal to 25, which is equal to R squared. Okay, so there we go. We found R squared. And so that means that the equation of the circle is X plus 2 squared. Okay, we're just using this one because R squared was the only thing missing here. Plus Y minus 3 squared is equal to 25. And that is the equation of our circle. Okay, moving on to the next question. The next question, 4.2, says, write down the coordinates of C. Okay, so we need to find the coordinates of C. Okay, so the only thing we're told about that is we have BA and BC, which are tangents to the circle. So these are tangents to the circle. Well, that would also mean that they are equal in length. I don't think that's important here, but it's good to take note of that. And what else they say? Since it's a tangent, okay, we can actually use something here. So we can use something from Euclid here. Do you remember that if you have a center of a circle, right, and you're going from the center of the circle to the circumference, then that is a radius, okay? So center to the circumference. But there's something we know about the radius and a tangent to a circle, okay? The radius and the tangent are always perpendicular at the point of contact. So what that would actually mean is, you see this line MC or CM? That line is actually parallel to the x-axis, making it a horizontal line, okay? And it's parallel to the x-axis, of course, because it is perpendicular to this line, which is parallel to the y-axis. So we have a horizontal line here. Now, why is that important? That's very helpful because that can actually help us to find a specific coordinate of C. So we have an x and a y coordinate, right? But are you thinking about this? If this is a horizontal line, it means that whatever y value this is, which is 3, so on the y-axis, this is where 3 is, it means that this point C has the exact same y value. So now do you see that the only thing we have to find is this x value over here? And that's what we're going to go ahead and do. So how do we find the x value? We found the equation of this circle. And do you see that this is R squared? If R squared is equal to 25, what is the radius? And I think this is how we can actually find it. What is the radius going to be? So R squared equals 25. It means that the radius, if you square root both sides, R would be equal to 5. You don't have to say plus or minus because it's a radius, which is a distance and can never be negative. So here's why I say that's important. You see, you know this is 3 already. You just want to find out exactly what C is. There's another thing we know here. We know exactly what x value is here. The x value here is -2 because this is the middle. Went -2 and 3 units up to get that point M. So this is -2 over here. But you know the radius, right? You know that the length of the radius is 5 units. If the length of this radius is 5 units, it means you're just going on the x-axis from -2, and then you're going 5 units to the left to get to C. Okay, because that is the distance of the radius. That is 5 units. And that's how we can actually find that. So -2, 5 units to the left, that's -5, and that would give you that value over there. So I'm going to find x by saying x is going to be equal to -2 minus the 5 units, going 5 units to the left, and that gives us -7. Okay, I already knew that the y value was 3. And I think I should have said that in the beginning. So I already knew the y value was 3 because of that being perpendicular. Okay, I don't think we need to say that, but we can tell them that CM is perpendicular to BC. Okay, and therefore it means that the y value was 3. And so it means that C, the coordinates of C, is really just -7 and 3. And there we go. And that's how we find those. Okay, so remember, we already knew the distance of the radius. So we know we're going from -2, 5 units to the left to give you -7. And we know this is 3 because of those are perpendicular. So this is a horizontal line. They share the same y value. Okay, so that is it for that question. It's a 2-mark question. So yeah, it's a good thing I went through this route because that is really all we need to do. You don't have to overthink this one. Okay, moving on to the next question. The next question, 4.3, says determine the equation of the tangent AB in the form of y equals mx plus c. Okay, let's look at AB. So AB is this. Do we have anything about it? We need to keep filling in things. So that is -7, and I'm just going to erase these because we don't really need those there. Okay, so AB, to find the equation of AB. Well, we don't have B, but we do have A. And we know the radius, right? We know what the radius, well, we know the length of the radius, but we have coordinates to actually calculate this gradient of this radius, okay? The gradient of that. And the reason why this is important is because, again, this is a tangent. And you know that your tangent, let me actually make that red as well. You know that the tangent and the radius is always perpendicular at the point of contact. So it means that if you find the gradient of this, because these two lines are perpendicular, the gradient of AB multiplied by the gradient of your radius, AM, when you multiply them, they must give you -1. So that's how we can actually find that gradient of AB so that we can find the equation of AB. Okay, let's go ahead and do that. So I'm going to take A and M, those coordinates down, so that we can go ahead and find that gradient of the tangent. So here's A and M. So we'll find the gradient of AM. Remember, AM is just our radius. We're just finding the gradient of that first. So that is y2 minus y1 over x2 minus x1, which is equal to, and so we're saying 3 minus -1, which becomes a +1, over -2 minus, and that's just a 1. And so the gradient of AM is equal to, that gives you 4 over -3. Okay, so it means that if you wanted to find the gradient of AB, which we know is perpendicular, okay, to AM, you're going to multiply those. But here's a quick way to find it. You see, ultimately what we're actually doing is you're just swapping the numerator and the denominator, and then you're multiplying that by -1. That's really all we're doing there. So it means that the gradient here would be +3 over 4. And that's what we're really just doing the whole time when we are working with those perpendicular lines. So we know the gradient of AB. We also have 1 point on AB, which is more than enough for us to find the equation of this line. So we're going to use A, and I'm going to use that quick straight line formula. So y minus y1, Okay, so here's our A. I'll take this as my x1 and that is my y1. So I'm not writing the full equation because I've already written it in the previous question. Okay, so y minus y1 is -1. So that becomes minus -1, which of course will become a +1, is equal to our gradient, which is 3/4, multiplied by x minus x1, and x1 is just 1. Then we just have to simplify. So this is equal to 3/4x when we distribute, and minus 3/4. Then we take our +1 over and it becomes a -1, and we have y here. So y is finally equal to 3/4x, and you have to subtract. You see, 1 can be written as -4/4, that -1, right? And so numerator minus numerator, that's -3 minus 4, which gives you -7/4. The denominator stays the same since we are subtracting. And that is our answer. So that is the equation of that line AB. Okay, moving on to the next question. Okay, 4.4 says determine the length of BC. Let's go ahead and see what BC looks like. They want us to find the length of BC. Now here, this is a vertical line, right? So with vertical lines, you just have to take the y value, because it's a y value. Take the y value of the highest point, and if you subtract it by the y value of the lowest point, you're going to end up with the distance of that line. So all we have to find is the y value of B. That's our goal, because we already have the y value of C. It's 3. We know exactly what that is already. So let's go ahead and find the y value of B. And how can we find that? Well, we have the equation of this line, right? We just found it. We found the equation of this line to be 3/4x minus 7/4. And we also know that this is a vertical line. So do you see that C has an x value of -7? Because it's a vertical line, it's not moving anywhere like left or right. It's just perfectly straight like that. So it would mean that B will also have that exact same x value as well. So B is -7 and something else, a y value. Okay. And here's the thing, because we have the equation of that line and we have an x value, why don't we just substitute that x value in here to find its y value? Okay, so that's what we're going to do. So I'll first of all tell them that I found that the x coordinate of B was -7, right? And I have the equation of that line that we just found, that AB. So I'm just going to substitute to find the y value. So we're saying y is equal to 3/4, and in place of x, we're substituting our -7. And then minus 7/4. And I'm just going to go ahead and use a calculator because it's not really necessary to just calculate it with hand. And we have -7. Okay, so the coordinate there for B is actually -7 and -7. Okay, so that is at the x and the y coordinate. Okay, so that is it for that question. Moving on to the next question. Then question 4.5 says, determine the equation of the circle centered at A that has both x and y axis as tangents. Okay, interesting. So we have to determine the equation of the circle centered at A. So this is where A is. We have A over here. And let me just get rid of every other thing. Okay, I just decided to copy this because I don't want to keep scrolling up. So we have to determine the equation of the circle centered at A. Okay, I should have gotten rid of that. But we have a circle, right, centered at A. And the only thing they tell us about the circle is that the x and the y axis are tangents to that circle. Okay, so it's really not a complicated thing. We just have to think about it like this. So we have x and y axis being tangents. You see, the minute something is a tangent to a circle, it means that the circle is going to have contact with it, right? If you know that this is the center and the tangent is going to have contact with the x and the y axis, then it means your circle kind of just looks something like this, right? And then it's just perfectly touching the x and y axis. And then the center is there. Okay, so something like that. So we have to determine the equation of this circle centered like that. Well, this is already hinting at a lot of things. We can actually find the radius of this circle, first of all, because we know that this circle, it has a center at this, and then it touches the x-axis. We can actually find it like that. So here, this point is 1 and -1, meaning when you are at the origin, you must have gone 1 unit to the right, right? That's 1. And then you went -1 units down. That is already telling you the length of your radius, because if you're going 1 unit to the right to get to the center, look at it like this. Imagine I was here and I went 1 unit to the right. I already know that the length of the radius is 1 unit. Okay, if you didn't see it like that, see it as when 1 unit to the right, and then now you're touching, okay, the circle or the circumference of the circle, and then you went 1 unit down. So we can already see that the length of that radius is 1 unit. Okay, so we have the radius, it's 1 unit, and we have the center. That's all we need. So instead of taking this as x and y, we're going to use it as a and b. We just need the formula of the equation of a circle, which is, we already had that there, x minus a all squared plus y minus b all squared equals r squared. Okay, so x minus our a value is 1 minus 1 squared plus y minus our b value is -1, and that becomes plus 1 all squared is equal to our r squared is 1. So 1 squared gives you 1. And that's the equation of your circle centered at A if the x and the y axis are tangents to that circle. Okay, so that is 4.5. Then moving on to 4.6, which is the last question for question 4 and for analytical geometry. Okay, we are on question 4.6, and it says, if another circle with center N, which is P and 3, and a radius of 4 intersects the circle centered at M at 2 distinct points, determine all the possible values of P. Okay, so we're going to need the diagram in this situation. So let me get the diagram. Okay, here is our diagram. And what they're saying is, if we have another circle, so I don't know what that circle looks like, but we have another circle and its center is N, which is P and 3. So that is actually a very interesting point, because we know that we have points here with 3. Even C had a 3. C's point was -7 and 3, right? So it has a y value of 3. So -7 and 3. So if that circle has a y value of, its center has a y value of 3, then it means that that circle, right, the center is horizontally in line with this circle center as well. So that's what we're going to have. We're going to have that circle somewhere. But what they told us is that this circle has a radius of 4 units, and it's going to intersect this circle at M at 2 distinct points. So it needs to intersect at 2 distinct points. So we have to now determine all the possible values of P for which this can actually happen. So what should be the values of P for another circle with a center N to intersect with this circle at 2 points? That's really the question. Okay, let's go ahead and see how we can actually construct this. So first of all, I don't know what that circle looks like. So it could be a bigger circle. We'll see, right? Let's just say we had a circle, and let's just read more into it to see what exactly the circle looks like. They told us that its center is at P and 3. So it is horizontally in line, okay? So it's not going to be like lower or higher. It's just in line like that. So what we have is that the radius is 4 units. Okay, so that helps us a lot. Do you remember this circle centered at M? What was the radius of that circle? The radius of that circle, which we already saw in the previous questions really, is 5 units, because we know that when we found the equation of that circle, we had that, well, there it is, okay? We had the 25. R squared is equal to 25, so the radius is 5 units. So we know that this circle that they're referring to is smaller than the circle centered at M. So because its radius is 4 units. So let's say it's something like this. And what we need to ensure is that this circle intersects the other circle at 2 distinct points. So I can actually see 2 places that this circle can actually be. It can either be here on the right, Okay, so the reason why is because let's just say it is in line, right? And we have our P over here, the center of it. So N, I mean, right? Which is P and 3. So it's in line, horizontally in line. What happens here is that if this circle has to intersect the bigger circle at two distinct places, it needs to move to the left. So there, it starts intersecting at two distinct places, two places again, two places again, and it will keep intersecting at two places as we keep moving it until it gets to this point. Then it stops intersecting at two places. It only intersects at one place. And if you move it further, it doesn't intersect at all. So we need it to intersect at two places. So that's what I mean by there's this place here that you can put it, but there's also this place. Because you see, the thing is they didn't tell us what P is. They didn't tell us that P is positive or negative. So we don't know that. They didn't tell us that it's in the first quadrant or anything like that. So it could also be here. You could also have it here. Okay. But I think it's better to deal with this case first, and then we'll work on that second case. Honestly speaking, with this, I don't think we need any formulas. It doesn't look like a kind of question that needs formulas. We really just have to work with what they've given us. Remember how I said that the radius of this circle is 5 units? That is going to be very helpful. So let's just watch how this thing moves and see how we can manipulate P so that it always intersects with this circle at two places. Okay, so let's go ahead and move this. So here, it doesn't intersect at two places, it intersects at one place. And then when we move it to the left, in other words, when P, right, whatever P is right now, if P becomes a value lower than that, then it starts intersecting at two places. So the first goal we have is to find out what exactly is P at this point. What exactly would P be when your two circles are only intersecting at one place? Okay, so let's find that. We can actually find that here. And how we can find that is this. Do you see that we know the radius of this? So then we know this is 5 units. And we know this is -2 and 3. So it means that over here we've got our -2. And we know that 5 units away is our radius. So if you count the distance here, this is 5 units. So we can find out where exactly these two intersect. So 5 units away from this point, -2, would be -2 and then +5 because we're moving to the right. So that is going to be +3 that we have over here. Okay, we have +3. Now, what do we know about this smaller circle? Well, don't we know its radius? We know its radius. We know the radius is 4 units. So for you to get from the circumference, because this is where they both meet, its circumference to its center, you're just going to calculate the distance of 4 units. So you're going from 3 and you're moving 4 units to the right. So that's 3 plus 4, which gives you 7. So we know exactly where they intersect. Okay, that's good. So we know that P, first of all, just need to be values that are less than 7, because the minute P is less than 7, it starts intersecting at two places. See, less than 7 intersects at two places. But we can't just say P is just less than 7 and we just keep going. That's not going to work. If you keep moving this and we say it's less than 7, where do we stop? Because if you keep moving and just P being less than 7, at some point it doesn't even intersect anymore. It's not intersecting at all. So the last place we should move it is to this point, because you see here it's still intersecting at two places, and we just need to let it sit on the other circle. This is the last place they intersect. So it needs to be less than 7, but it shouldn't go beyond this. So remember, just focus on what exactly P stands for. P is the center of that circle. It was the center of the circle here. It's still the center of the circle here. So we still need to find out what exactly the center of this blue circle is. The center of that blue circle, not so difficult to find, because now we know this is 3. We know that they will both touch at this point here where x is equal to 3. And we know that this radius, the radius of the blue circle, is 4 units. So just go from 3 and go 4 units to the left. So that is 3 minus 4. And if you go 3 minus 4, what do we get? So 3 minus 4 gives you -1. That means that the center of the blue circle is now going to be here at -1. So what that means is our P values, what they need to be for this circle to always intersect with this circle at two distinct places, is P needs to be less than 7. So we're like this, needs to be all values that are less than 7, but it should not go anything beyond -1. That p-value, the center of that circle. How we can write that is like this. We can actually say that p needs to be greater because it shouldn't go anything beyond -1, right? Meaning it needs to be values that are bigger than -1. So greater than -1, but less than 7. Okay, and that will be the first part. That is if the circle was actually on the right-hand side. So I'll put that down because that is definitely a solution. That is p needs to be greater than -1, but less than 7. Then I'm going to say or because this doesn't only happen here. So I'll leave the circle here just so that we remember how that worked out. And let's take this and also just copy and paste it here. So it could have also happened here as well. In the same way, see, if we can figure that one out, this one shouldn't be difficult to figure out. So it can also intersect with this circle at 2 distinct places here. So when we have it here right now, we don't exactly know what the center is because once we start moving it to the left, it starts intersecting at 2 places like we wanted to. So we need to find out what exactly the center is at this point. The center of this circle, well, to find that, we can actually find that here because we know what exactly the center of the bigger red circle is, right? The center of the big red circle is -2. And we know that its radius is 5 units. So go from -2 and go 5 units to the left. So that's -2 minus 5. And that's going to give us -7. So we know exactly what the x value is at the point that they meet. So it's at -7 that we have there. And then to find the center of this blue circle, we're going to go from -7, and we know that the radius of the smaller circle is 4 units. So we're just going 4 units to the left. That's -7 minus 4. And that gives you -11. So we know the center. That's good. And now that we know the center, we're saying that the center, the p value, because that's really what they're saying p is. They said the n, right, is the center of the smaller circle, which is p and 3. We're saying that our p value needs to be values that are, first of all, greater, because we're moving to the right-hand side this time, greater than -11. See, there it intersects at 2 places, keeps intersecting at 2 places. Where should we stop? It keeps going, still intersecting at 2 places until it reaches here. And if you go anything beyond this, it's not even intersecting at all. So we need to stop here. So remember, we're trying to focus on the center of the blue circle. What exactly is the center of the blue circle at this point where this circle and the bigger circle circumference meet? So what exactly is that going to be? Well, we can find that because this circle, its radius, the blue circle's radius is 4 units. And we know they intersect at -7. So just go 4 units to the right. So that's -7 plus 4, which is going to give you -3. So that would be the center over here at -3. So it really just means we're taking the circle and we're moving it, right? It needs to have p values. The center needs to be values that are greater, because we're moving to the right, than -11, right? Greater than -11. Is it just greater than -11? No, because if you keep going, it doesn't intersect anymore. It needs to stop here. So greater than -11, but less than -3. It shouldn't go anything beyond -3, the p value, that center. So that would be our answer there. So or p needs to be values that are greater than -11 but less than -3. And that is our answer. So that's what I meant by I don't really think we need a formula for this. We really just need their radiuses or their radii. That's all we need. So that is it for that question. As you can see, that is the last question for question 4. Question 4 is a total of 20 marks. And we move on to question 5, or really just trigonometry.